You know, we walk on it every single day. But have you ever really stopped to think about what's going on right under our feet? Well, we're about to take a journey of scale, to see what the ground we stand on is actually made of.
It seems like such a simple question, doesn't it? I mean, it's just dirt, right? But if we could zoom in, like way, way in, what would we really find? What is that stuff fundamentally? Believe it or not, the secret to understanding pretty much everything about soil, why some is great for farming and some is just a desert, it all boils down to one super simple factor: the size of the tiny little particles it's made of. Okay, so let's start our journey with the big stuff. The particles you can actually see and feel without needing any kind of microscope.
First up is gravel. This stuff is the heavyweight champion of soil particles. It's coarse, it's hard, and yeah, you can definitely see it. No special equipment needed for this guy. So, just to give you a sense of scale here, anything bigger than 2 millimeters, that's gravel. You can literally pick up a single piece and turn it over in your hand. It's the perfect, most tangible place for us to start.
All right, let's shrink things down a bit and talk about sand. We all know what this feels like, right? That classic, gritty texture you get at the beach. You're actually feeling all those individual particles. They're just a whole lot smaller than gravel.
So the size range for sand is from about 0.05 millimeters all the way up to 2 millimeters. So basically, right where gravel ends, sand begins. It's a pretty big step down in size, but we can still feel those individual grains.
Okay, so what does this size actually mean in the real world? Well, think about it. All those large spaces between these bigger particles mean water just drains right through. Gravel has super fast drainage, and sand doesn't hold on to water for long either. And this is absolutely crucial for figuring out what can, and maybe more importantly, what can't grow in it.
All right, time to zoom in again. We're leaving that gritty world behind us, and we're entering a much smoother, much finer dimension. It's time for us to discover silt. Let's talk about the feel of this stuff. Silt is so fine that when it's dry, it feels incredibly smooth and soft, almost like flour. It's a totally different feeling from sand. And here's why. Just look at that size range, from 0.002 all the way up to 0.05 millimeters. You know what that means? The biggest piece of silt is the exact same size as the smallest piece of sand. Yeah, we are getting seriously tiny now. Now, because those particles are so much smaller and packed closer together, silt is a real game changer. It can hold way more water than sand, which in turn makes the soil a whole lot more fertile. This is where soil starts getting really good for growing things.
Okay, get ready for the final jump down the rabbit hole. We're going to the microscopic level now to meet the smallest and, in a lot of ways, the mightiest particle of them all: clay.
So this is it, the final and smallest type of soil particle. And it has this really fascinating split personality. When it gets wet, it becomes super sticky and you can mold it. But when it dries out, it gets as hard as a rock.
So why does it act like that? Well, it's because of its incredible size. Clay particles are anything less than 0.002 millimeters. I mean, that is truly microscopic. There's no way you're seeing an individual particle with your naked eye.
And that tiny size is where its real power comes from. Because the particles are unimaginably small and packed so tightly, clay holds the maximum amount of water. Those spaces between the particles are so tiny that water just gets trapped, making it the undisputed champion of water retention.
So we've journeyed from the stuff we can see all the way down to the microscopic. Now, let's put it all together and see how these different particles stack up side by side. And here it is, the whole story. See how it all lays out? On one end, you've got your massive, coarse gravel that lets water just rush right through. Then you move to sand, which is smaller and grittier, but still pretty bad at holding water. Then you hit silt, that big jump down in size, and suddenly it feels smooth, and it's starting to hold water really well. And finally, you have microscopic clay, sticky, and the absolute best at holding onto water. It's just a perfect progression from large and loose to tiny and tight. And that's really the big takeaway from all of this. The feel of the soil, its ability to hold water, how fertile it is. Literally everything comes back to that one fundamental property: the size of its particles. It really makes you think, doesn't it? If something as simple as particle size can create such dramatically different worlds in the ground right beneath us,
What other seemingly tiny, overlooked details are having a huge impact on the world all around you?